Hi, my name is Kindra Snow-McGregor, and I am the engineering manager for John M. Campbell Consulting. And today I'm going to discuss my tip of the month, which was January 2009 Process Engineering Design and Safety Tip of the Month. The reason why I wrote this tip of the month is because, being a design engineer for my entire career, one of the most important aspects of facility design is ensuring that your process safety system is designed adequately and will protect both the equipment and the personnel for any operating conditions that may occur. In my tip of the month, there's some pretty interesting statistics from a study that was done by Berwanger that discusses the percentage of facilities that do not comply with industry standards and guidelines for pressure safety protection. And it's been my experience in doing both plant debottlenecking and say relief system audits, where frequently you will find in both new and older facilities that the equipment, the pressure relief system and relief valves frequently have problems and issues. For example, pressure safety valves. They found that 65% of the processing facility pressure safety valves did not meet existing standards. And the ranges or the reasons for this varied. But frequently, what happens is that the original design engineer didn't consider the correct relieving conditions, and so they missed the scenario that was limiting, and then that scenario occurs and there's a horrible accident. For example, in 1998 there was a major vessel failure because a low pressure vessel was open to a high pressure source, and the vessel exploded and 4 people died. And so it really is, it's a very serious thing. And I really hope that anyone who's designing these systems reads both API 520 and 521 and has a good understanding and can be able to think through the process to ensure that there isn't a scenario out there that was missed for the calculation. Another thing that you'll find in the field, which is actually quite amazing, is on occasion I have come across facilities where the operators have decided to increase the set pressure of their PSVs because the PSVs kept going off. And so instead of determining what was causing the process upset and keeping the process within the design limits of the equipment, their shortcut method to resolve the situation was to increase the set pressure on their PSVs. And what this will result in is that the equipment could potentially be exposed to pressures greater than what it was originally designed for. So that's another important point about process safety design, is even if you put something in that's designed correctly, you need to be sure that your operations personnel is trained and understands the purpose of those devices and doesn't shortcut or interrupt the method of protection because they don't understand why and how the valves work. Another important aspect of these designs is the inlet and discharge piping. If the piping design isn't adequate for the flows that you need to pass, the equipment can see overpressure. So PSV inlet and discharge piping, it's very important to be sure that your inlet and discharge piping is designed adequately. If the hydraulic calculations are not correct and you're not within the recommended guidelines of 3% on the inlet, and then the back pressure on the discharge of the valve will be set by the valve type. So if you're greater than 3% on the inlet, what can happen is that the pressure will build up and then the valve relieves. And then once it relieves, the pressure hasn't built back up again and it causes chatter. And when this occurs, the valve and piping can fail. On the other hand, if you have too much back pressure on the downstream side of the valve, essentially what that will do is choke the flow going through the orifice, and so the valve won't be able to relieve the flow that it needs to, and again you'll result in overpressure. Again, there's additional details in my tip of the month. Another thing that's very important is to understand the thermal stress that you have on the piping. Frequently there are some temperature extremes that can occur through relief systems, especially if you have auto refrigeration as a result of high pressure hydrocarbon letdown, which is very common in our industry.